Let's take a look at section 4.7, vertex form and transformations of graphs. Like much of this section we've already discussed and you know how to do. We've really looked at vertex form since the beginning of the unit. So recall, vertex form is y equals a times x minus h all squared plus k. And remember, the vertex is h comma k. Okay, it also tells us our transformations. How much to the right or left did I go? Did I move up or down? That A value tells us if we have a stretch or a shrink or a reflection. So we have talked about vertex form to standard form where we FOIL and distribute. Now we're going to go in the opposite direction. We're going to start in standard form and work our way to vertex form. So there's a few ways to do it, but I will walk through one set of directions. So the first thing we're going to do is move the constant over to the other side of the equation. In this case, we're going to move it to the left. Now I have y plus 1 equals x squared plus 6x. After that point, what you need to do is factor out the coefficient of the quadratic term. Notice, this is different from completing the square steps where we divided through. Here, we're just factoring it out, but keeping it. The good news about the problem we're working on is that a value is already 1, so we don't have to do step 2. So now what we're going to do is step 3, which is to actually complete the square. So I'm going to grab a different color, and to complete the square, we take half of our b value. So in this case, it's half of 6, which is 3, and we square that, which makes 9. What we're going to do is add that to both sides. So we will have y plus 1 and x squared plus 6x, but I'm going to add that 9 to both sides. From here, we can clean things up and we can factor. So the left-hand side, I'm just going to combine my like terms of y plus 10. And the right-hand side, because we factored and made a perfect square trinomial, it can factor to become x plus 3 all squared. Lastly, to get that in vertex form, we just need to get y alone. So I will subtract 10, and I find that y equals the quantity of x plus 3 all squared minus 10. And there is my vertex form. That easily now tells us what my vertex is, right? So the question says, put in vertex form, determine the vertex. So our vertex is hk, which is these two values. Remember, I used the opposite. So -3, -10 is my vertex. My a value is positive, so that means the graph opens up. I'll have a parabola opening up, so that means I will have a minimum. And the domain, of course, as we've been emphasizing, is always all real numbers, focusing on using that interval notation. And the range, we focus on the y value of my vertex, which is -10, and it opens up. So that means the lowest point I hit was -10, and since it opens up, it'll go to infinity. Okay? Let's look at number 2 together. So I will follow the same steps where I'm going to move my constant over. After that step, we have to factor out the quadratic term, which I have a coefficient this time. So notice what I'm going to do here. Y minus 16, I'm going to leave some space, equals, I'm factoring out the 2, not a GCF, just the coefficient. That leaves me with x squared plus 4x. I am not going to close the parenthesis yet. Okay, so I moved the constant over, and now I factored out that coefficient. Now I complete the square. So I'll take orange, and I take half of my new b value. So half of 4 is 2, and 2 squared is 4. That means I'm going to add 4 to that right-hand side, and now I can close the parenthesis. What is super important, and I emphasize super important, now remember, is that yes, it looks like I added 4 to this right-hand side, so I must do it to the left-hand side, but really I multiply 2 times 4. I really added an 8 to that right-hand side, so I have to add 8 to the left-hand side. Again, to complete the square, it's a 4, but if I distribute this out, I really have a constant of an 8. So I need to make sure that equation stays equal, and I put an 8 over here. On my first example, that coefficient was a 1, so when I added 9, I really added 9, so I just add 9 to the left-hand side. Okay, at this point now, we will simplify and factor. So my left-hand side becomes y minus 8 equals the right-hand side. I have my coefficient of 2, and now I factor that trinomial, which will be x plus 2 all squared. Lastly, isolate the y value, so 2 times x plus 2 all squared plus 8. And there is vertex form. Our vertex in this case is hk, negative 2, positive 8. The graph is going to open up again because it's a positive a value, so that means I'll have a minimum. The domain is all real numbers, interval notation, negative infinity to infinity. And the range, since it opens up, it means the lowest point is 8 and the highest is infinity. Okay, you try number 3. This one is very, very straightforward because there isn't a constant and there's also not a coefficient. So you can jump to step 3 of completing the square and then finish it. Let's review our application with our position function. So with our position function, remember, we either are going to have negative 16 or negative 4.9, depending upon feet or meters. And we have t representing our time, v naught is our initial velocity, h naught is our initial height. So if we look at our example 4 here, the first application on our notes, it says to celebrate July 4th, the town of Trigon has hired Pyrotech Inc. to launch fireworks from an 80-foot tower in the center of town. The rockets can be fired with initial upward velocity of 64 feet per second. Write a vertical motion model for this problem. So what I want you to do right now is pause the video and come up with the model that you will use. So fill in the unknown variables and constants for the general equation. Pause the video and do that. And then when you start the video back up, I will have written the answer. Okay, so you should have gotten h of t equals negative 16t squared plus 64t plus 80. We're choosing negative 16 because we are talking about feet in this problem. Our t is our variable for time. V naught is initial velocity, which they told us is 64. And our initial height is where we're launching those fireworks, and we're launching them from an 80-foot tower. Once you have that equation, you can answer the rest of the questions. When does the rocket reach its maximum height? And what is that height? So when and what is the maximum? So what does that mean to do? It means to find the vertex. You can do this in 2 ways now. You can use negative b over 2a, like we did in the past since it's in standard form, or you can rearrange this equation to vertex form just like we did above. Okay, you complete parts B And then also complete part C, which is how long until the debris hits the ground. Remember, the ground's height is at 0. Okay, so you'll have to set to 0 and solve. Complete B and C. Number 5 continues on with a fireworks show. And this time around, they give us an equation, and that equation is in vertex form. Okay, so we're not using our equation from up above. This equation is given this time in vertex form. If you were to FOIL it out, you would see that it would give you standard form that looks similar to our general equation, but because we're talking meters, we see the negative 4.9. Now, this one is going to be super duper easy because we're in vertex form. So when it says when will it reach its maximum height and what is the maximum height, again, we just care about the vertex. So I can look at this problem and see my vertex is 4, 80. Right here, all of my answers are given. What we need to remember is that when it says when, that represents the x value or the t, right? Instead of x's and y's, we're working with t's and h's, time and heights. So when will it reach its maximum? It'll be the 4. So at 4 seconds. And what is the maximum height? That'll be the 80. And remember, it's in meters this time. Okay, so the point of this question is to show you how nice vertex form is to being able to find your vertex and maximums. Whereas in the problem above, we were in standard form, so it requires more work. Okay, the last thing that you're going to look at is writing an equation, which we've done a bunch of. We've looked at different scenarios, given a graph, write the equation, given 3 points, write an equation. So today we're going to just be given 2 points and we need to write an equation. However, one of those points is going to be the vertex. So when you're given the vertex, you should always start with vertex form. So remember, vertex form is y equals, or f of x equals a times x minus h all squared plus k. Okay, because we know our vertex, I have my h value and my k value. Okay, now, well, that would mean we can fill in for h and k. But we also then have an x, an a, and a y. But the good news is I have an additional point. A point represents an x value and a y value. So now I have all the missing pieces for my equation except for a, which is what I'm going to go solve for. So I'm going to take my y value, which is 1, and plug it in for y. I don't know a. I'm going to take my x value, which is negative 1, and plug it in for x. My h value is negative 2. So remember, it's a negative 2, all squared, plus my k value is also a negative 2. Now I will simplify that. So I get 1 equals a times negative 1 plus 2 is really 1 plus negative 2. Keep on simplifying. Make this a little prettier. 1 equals 1a, or a minus 2. Now to get a alone, we add 2. So my a value is 3. This now tells me what my vertex form is. That vertex form will be y equals, our a value is 3, times x minus h. My h value is negative 2. So remember, minus negative 2 is really plus 2, all squared. And then plus k, in this case, minus 2. So when we're writing our equation, we want x and y to be blank, but we need to know our a value, our h value, and our k value. H and k were given, and we solved for a. The question also says put it in standard form. So this you should all be pros with. What you're going to do from here is just FOIL. So go ahead and find your standard form.